looked at a plastic product and wondered why it's hollow inside? Most people assume manufacturers are just trying to save money. But what if I told you that making many plastic parts completely solid would actually make them heavier, more expensive, and in some cases even weaker? Today, we're going to uncover the engineering hidden inside everyday plastic products and see why empty space can be one of the smartest design choices an engineer can make. Now let's stop the chatter because these layers matter. Welcome back to the channel. When people see an empty plastic part, they usually think one thing: the manufacturer's cheaped out. But engineers don't design parts by asking, how can we use less plastic? They ask, how can we get the strength we need with the least amount of material? That's a huge difference. Plastic doesn't behave like steel. Most of the plastic part's strength comes from the outer walls, while the material inside often contributes very little. So instead of making the entire part solid, engineers create an outer shell and reinforce it with internal ribs exactly where extra support is needed. Think of it like a house. The drywall isn't what keeps it standing. It's the framing behind the walls. Plastic parts work the same way. The hollow space isn't missing material, it's engineered space. But if hollow parts work so well, why not just make everything solid? Well, here's something most people don't think about. Plastic starts as tiny pellets that are melted and injected into a mold under high pressure. As the plastic cools, the outside hardens first while the center stays hot much longer. If a part is too thick or completely solid, the center continues shrinking as it cools. That can create warping, sink marks, internal stress, and parts that don't come out exactly the same every time. By keeping the walls a consistent thickness, engineers help the entire part cool more evenly. That leads to stronger, more accurate, and more reliable products. There are other advantages too. Using less plastic makes products lighter, and lighter products cost less to ship. They're often easier to handle, and manufacturers can produce them faster because there's less material that needs to cool before the mold opens again. Saving just a few seconds on every production cycle becomes a massive advantage when you're manufacturing millions of parts. So if engineers are removing material, where does all the strength come from? Strength isn't about using more material. It's about putting material in the right places. That's why you'll find features like ribs, gussets, screw bosses, fillets, and other structural supports hidden inside plastic products. Each one has a specific purpose. Some increase stiffness, some spread loads across the part, others reduce stress, so cracks are less likely to happen. Every feature is carefully placed. This design philosophy is called optimization. Instead of asking, how much plastic should we use? Engineers ask, what's the least amount of material we can use while still meeting the performance requirements? That's why you'll find hollow structures inside power tools, kitchen appliances, cars, medical devices, and even the phone you're probably watching this on. Empty space isn't wasted. It's part of engineering. So next time you break open a plastic product and it's hollow inside, don't assume that it's cheap. You're looking at decades of engineering focused on making products lighter, stronger, more reliable, and easier to manufacture. Sometimes the smartest design isn't adding more material, it's knowing exactly where you don't need it. If you enjoyed uncovering the hidden engineering behind everyday products, subscribe so you don't miss out on the next project. Because it helps us out more than you know, and it's free. Thanks for watching, and we'll see you in the next one. Also, if you enjoyed this video, YouTube thinks you'll like this one next.